Hi guys, how's it going? So today we're going to be looking at this question. It's called get top n frequent weights. So essentially, in simple terms, what they're saying is that if we're given a text like so, we just need to find the top n most occurring weights, right? So let's say n is 3, so you know that you have to get like top 3 weights within this text. So for instance, there is occurring the most with, I think it's occurring 6 times. Then what you're gonna do is that you're gonna say, okay, there equals to 6, right? Then I think the next second occurring word is gonna be herbal. So which is herbal is occurring twice. Then if you also count, you will realize that actually sauna is gonna be the third, which is also occurring twice. So we have 3 words which are occurring the most, sorted by their frequency, right? So that's what this question means essentially. You can see also from the output, this is what they have. So this is what we need to solve. We need to build an algorithm that can do this for us, okay? The question is, how can we go about this? One way someone can say, okay, cool. Because of strings are immutables, the first thing we're going to do is that we're going to try to create split these weights into like individual weights. So split this string into individual weights. The next thing, you try to loop through that. So you can think of like with a list, and this list is holding all of these weights, like, herbal, it is its own weight. Then you have sauna, it is its own weight. Then you have use, it is its own weight, right? Then what we do is that we loop through this. So we loop through this, then we store these in a dictionary. So for instance, we can think of like the first thing that we're going to do is to go through herbal, right? Then we store herbal, but with the frequency. So far, herbal occurred once, so we're going to write 1. So we go to the next word, which is sauna. So far, sauna occurred once, we write 1. Use, so far, use occurred once, we write 1. So we do the same thing. We do the same thing from all of these words. We do the same thing. But when we get to there, we realize that, okay, there is actually there, right? We did right there. Let's say we already had there here, right? So when you get to the second there, you realize that, okay, I did have there. So which means that this will increase to 2, right? You go, you get to another there, you realize that, okay, now I have 3 there, so it's going to store here, right? So you can imagine that you're going to have all of these weights and their frequencies, right? Now, what is the step 3 from this, right? You have a dictionary with their frequencies. One way you can say, okay, cool, how about I store all of these things, I sort them, right? So that I can get the top n, because don't forget the objective is to get the top n weight. So one way you can, okay, so I'm going to apply the sort algorithm to sort these frequencies. So you can imagine that essentially you're going to sort them. You're going to get like the first weight is going to be 6, then the second one maybe is going to be 2, like just like that. You're getting their frequencies, like so, like, right? Then what you're done, once you're done, is that you get the top n. For instance, the top n in this case was 3. Then you go from like 0 all the way to 3, so it's going to be 2. Then you get those elements, so it's going to be 6, 2, and 2. Okay, because of their sorted, right? We know that the sorting algorithms, they are sorted, so the biggest guys are going to be here. So you already know that. Then going down is going to be the lowest guy. So that's why you're getting the top 3, because these are sorted. That's like what you did here, right? So that's one way you can go about it. That's one way. But let's analyze the time complexity. How slow is this algorithm? So we're definitely using a sort, which is going to cost us n log n to run, right? And we have because we have to loop through, so we also have to add plus n here, because we have to loop through to create this dictionary, plus another n to store these in the list, right? Yeah, plus we have to loop through these constructed sort, because you have to get to, so you have to add plus k denoting the number of top n. Remember that you have to, after you've sorted this, you have to go all the way to k to get the top k, right? So it's going to be plus k there. Then what is the space complexity? We constructed this dictionary here, so it's going to be of n also. So yeah, that's that. But then the question becomes, how can we then improve this algorithm? How can we make it faster? Okay, so one way we can use max heap, sorry about that, because we're looking for the top. So that's why I'm saying max heap here. So we're looking for the top k. So we're looking for the values like with the biggest number. So that's why I'm using this max here. Essentially, max heap is a data structure that try to structure the data in such a way that the top values are going to be at the top, the small values are going to be at the bottom. So it's a trees data structure whereby you can have 10 here, you can have 9, you can have 8 here, like so. So you can see that if the top values are at the top, it's going to be much faster to get the top. So the top values, because this is how the data structure is constructed. Even if you have more values here, it's going to be much easier to get. So you don't have to travel through the entire tree or do some sorting to get there. So you can just get them from here, right? So that's that. But the point is that as you get these like you have to heapify this as you get this. So essentially to get this, it's going to be, let's say you want to get this top n, so it's going to be n log k. So for each k denoting the top k word, right? The top k word. So let's say this is 3. So for each word you have to get it with n log n. Does that make sense? So you have to like get it with n log n. But the point is that this is much better. N log k is much greater than n log n, which is used for sorting. So so this is way much better, right? So that's why we're gonna go with this approach to build this thing up. I know some of you might not know what is max heap, but I'll try to explain this from the code and you will understand it much better. Sometimes when I'm explaining these stuff on this Word document, it might be quite difficult to grasp, but as I go to the code, I still explain these things in a much more thorough and much more detailed way. So you will get a better perspective from there. Now coming to the code, the first thing that I'm going to do is to import the string. We're going to say from collections. So you can still, these are like small helper functions. If you're in an interview and they don't want you to use libraries, it's still okay. So I'll show you how you can do whatever I'm going to do without these libraries. So it's more like they are not necessarily going to be used that much. It's just like helper functions, I'll say. So the core logic, we're going to write it ourselves. So so we import heap q. So to implement, I doubt that in an interview they want you to implement a heap. I've also already done this video in the past. You can check one of my videos implementing this from scratch. So this is an interview on its own. So I doubt that the interview will say like build a data structure heap from scratch if you want to solve this question. So yeah, that's my take, right? So anyway, so the first thing that I'm gonna do to try to I'm gonna create this function called nFrequent. I'm gonna say nFrequent weights. So we're gonna take in the posting which we're given. So we're given posting and we're given n. Then from this, what I'm gonna do is that I'm gonna try to punctuation, to work around punctuation, like these commas here. So these are like more like edge cases. So let me just write this edge cases, because some of these words, if they have like a comma like so, they will be treated as one word. So we don't want that. So we want to not take into consideration these punctuations and stuff like that. So going to be posting. Then what we're going to do is that we're going to take in the posting. So by the posting, I'm referring to this text. You can think of we taking this text, right? So what we're doing from this text is that we're going to say dot translate. So I'm taking in the string function, then I want to translate this. So I'm going to say make trans. So I'm going to say replace this punctuation. So it's going to be string dot punctuations. So I don't have to write them. So if you're in an interview and they say, oh, no, you're not supposed to write a string, so it's fine. You can write these punctuation in a list, like so. Maybe we can do this, then something like this, and you can then loop through to remove them or something like that. So this is more like a quick helper function to remove them for us. Yeah. Anyway, so what we're gonna do is that we're gonna create a frequency. So we're gonna declare this dictionary frequencies. I'm gonna say default int. Then we're gonna say for weight in posting. So I'm just gonna say posting. Then I'm gonna lower this because if you can look close, I'm sorry that I didn't actually mention these edge cases when I was explaining, but it's important to take care of them. For example, there and there, you can see that this one is a capital letter D. So I think it's better if we kind of like lowercase everything. So these from these postings, and I'm gonna say lower, right? Lower. Then what I'm gonna do is that I'm gonna say dot split. So this split function essentially split, like I said, that we're splitting this into individual words. So we're creating a list. I hope that makes sense. Then we're gonna say frequencies. We're taking these words and we're storing them inside this dictionary. So we can think of like we're taking that dictionary and we say passing the word, then we say plus equals to 1. So by default, as you can see, this int, you can think of it as like it's 0. Then when we gonna say plus 1, so we're gonna start at 1. But if we see that word again, you can see that we say plus 1 again, so it's gonna be 2, right? That's what it does here. So just to visualize this so that you can understand what I'm talking about. So let's say you have a string like this, né? Then what we do is that we take this, we put it into a list. Then you can think of like here we have commas for each word, right? For each word. So like so, né? Then now these are, by the way, this lower function is going to make sure that this is lowered. So you're going to have something like this, right? The split, make sure that it's split like this. So they're in a list now. Okay. Then now this frequency, what does it do? This is a dictionary. That's why we said default dict. So what it does is it's just going to take this herbal, right? It's going to say herbal. Then it's going to say you are 1. And it's going to say Sauna. Then it's gonna say you're 1. But if it sees Sauna again, it's gonna say, okay, because we're saying plus equals to 1, it's gonna take it to 2. Right? So I'm explaining these because these Python functions sometimes they can be quite confusing for some people. So hence I needed to clarify that, right? So now we're gonna return none for now because I have to write the functions for us to work around. So the first function that I'm gonna create is to hippify frequencies, right? Hippify frequencies. Then we're gonna take in the frequencies. Then from here, what we're gonna do is that we're gonna return a list comprehension. We're gonna say for word and frequencies in frequencies dot items. So it's important for me to explain this. You can see how we're studying this, right? Like I showed you that we're starting with the word, we come with number, like word and number. We understand this. But when you apply the heap, the number has to be here. Have to be the first one. So essentially what we need to do is that we need to put the number here. So it's going to be minus frequency I'm going to explain that minus just a second. Then we put the weight here, right? So we can think of like this. So we can think of like we have 6 there, right? We have like 6, 6, and there, like so. Then we have another 1, 2, like Hebel, like so. This is how we're storing them. And your question might be, why are we storing them like this? It's because the function is gonna look at this number here, the heap function, for it to heapify this. So right, so now imagine if they were stored like this, then it was not gonna work, because the first weight, oops, I think I lost my, yeah, sorry about that. I don't know where it went, but anyway, so yeah, that's that. So now we can actually use this. So I'm gonna say get top and frequent, top and frequent weights. So we take in the frequencies, we take in n, okay, then we say heap equals to heapify. Yes, remember that for us to push this into a heap, so we need those, we needed a negative there because of by default this heap function, it's a min heap, so we're turning this thing around, so we're making it a max heap, so that's why we're putting it as a negative. So yeah, that's that. Then inside here I'm just passing in the frequencies, which we're gonna get those elements that I told you, like the first number and the weight. And now our function heap q can work with this, right? It can heapify this, so it can definitely heapify this. So we're gonna pass in the heap there, right? So then we're gonna return, I think we're gonna return, oops, sorry, return, I can't type, okay, sorry about that. Then what I'm gonna do, I'm gonna say for frequency, and I'm gonna say weight in heap heap q, right, dot n smallest. Yes, I'm getting the, like I said, that we turn this thing around, so we know that we turn these to negative, so instead we're looking for the smallest, but we know that it's the biggest one. It's just that we turned it around, so it's still fine. So I'm gonna say give me the n smallest, take this n, and I'm gonna give you the heap function. Okay, then here I'm gonna return the weight, and I'm gonna return I'm gonna cancel that negative. Now I want the actual value, because this is my final return. You see I have a weight and I have a frequency, and this is how the results looks like, right? So if you look at the, should copy this. So you see the result, we have a weight and we have a frequency, and this is what I'm returning. I'm returning a weight and the frequency. So I'm putting this negative to cancel the technique that we did here, so to kind of like reverse it back again. That's what I'm doing. I'm probably confusing you, and I'm sorry if I did confuse you. We're gonna go through this again, but yeah. So anyway, so we're gonna say get top and frequent weight, then we're gonna pass in the frequencies, then we pass n is the given top n, right? They said get top n, so they give us the n here. So I'm gonna run this code, and we have a mistake. So it says string has no attribute makes string. Oh, what is this called? It's called make, I think it's trans, make strands, like so, string makes trans, and it says that string has no attribute. Did I make a mistake here? So it's translate posting dot translate. I think it's fine. Okay, it works. So yeah, I think I made an error here, but yeah. Anyway, it looks like the solution works fine. I'm gonna submit, and it works. So yeah, so just to walk you through the final code. So the first thing that we do is that we remove the edge cases. So if we didn't do this, essentially, you see here, miracle was, and with the comma was gonna be considered a one word. So you don't want that. So what you want is that you just wanna remove this here. The second thing that we did also for the edge case was to lower the string. So for example, we have herbal here. So we needed to make sure that this herbal with capital letter H can be matched with this one. So yeah, I think that's all, and that's how the code works. Yeah, thanks guys. I really appreciate it. I'll continue to make these if you guys enjoy them. Thanks, bye.